The graph of f is shown in the figure. The most common mistake I see people making on these is they don't read the question properly. Sometimes it'll say the graph of f prime is shown. What does it tell you? It says the graph of f is shown. That is f, not f prime. Which of the following could be the graph of f prime? This right here is f prime. What are the key points to look at if you're trying to figure out the derivative? Where the function's derivative is 0. Where the derivative crosses the x-axis. We know that it looks like it's 0 right about there. So the function better cross the x-axis right about here. Well, that looks okay, right? This looks okay. That looks okay. But what about these two? Nope. No, definitely not those two, right? What's the derivative here? What can you tell me about the derivative here? Positive. So it has to be positive entirely to the left of there, right? Right here. What about this one? Oh, this one works too, right? It is positive. Do you agree? It is positive. So what one can we eliminate now? That one's definitely gone, right? What do we know about this one? It then says, what's the derivative right here? Has to be negative. So it could be this or this. How do we figure out which one it is? Well, let's look at this. The derivative on this side right here is negative, correct? Is it the same negative value the entire time? No, it's not. It looks like, what does it look like the tangent line is right here? It looks like it's a horizontal tangent. It looks like it's very close to 0. Does this look like it's going to 0? No, it's not slowing down. So which one is it? A. So this process of elimination. The most common mistakes, again, what are they in this type of question? What's the most common type of mistake on this type of question? Misreading the question. Misreading the question, absolutely. If you thought this was the derivative and you're trying to find the function, I bet the function is there if you reversed it. Be careful. Why is it not E? Why isn't it E? It isn't E because the derivative, look, the derivative is slowing down. Look, it looks like the derivative is 0 right here. It looks like the derivative is 0 right here. Is the derivative 0 here? What is it here?
Is the question?
Yes.
On number 19.
Hold on. A very common mistake is, oh, it's where the second derivative is here. No, that is a necessary condition, but is not sufficient. Change in concavity, so change in sign.
Like a squared or to a
yes.
There is a good
even powers. Yeah. And this is really cool because another way to get this one wrong, I bet people read that as f of x is that. Mm-hmm. I bet the answer's there. You take the second derivative, it's going to be fourth power. Wait, 1, 2, 3, fourth power. Take the second derivative, it'll be a squared, so there'll be 2. Might not even be those two. Does that make sense, everybody? We have the area related to radius, but we want the circumference. What is the rate of change of the area in square centimeters? Okay, so what do we have to do here? Any ideas? Well, let's just do it this way. Let's see what happens here. If we were going to relate right now, find the change in area, we can do that, right? Yeah. Correct? We differentiate both sides with respect to what? dt. Respect to time. So if we differentiate this, dA dt is equal to pi times 2r times dr dt. Is that correct? Are we okay with that?
Yeah.
But what is it saying? The radius of the circle is decreasing at a constant rate. So what can we replace here? What's the one thing we can substitute in? We know dr dt, right? So we know that dA dt is equal to 2 pi r times what? Times what?
Negative
0.1. Is that correct?
What is 2 pi r equal?
What is 2 pi r?
C.
What is 2 pi r, everybody? C.
And
this is
there
circumference.
That matches that? Yes.
That is circumference. It's right there in front of you. So you have the change in area is going to be negative 0.1 c. Is there one that matches that?
Yep.
There it is. Done. That's it. The key realization here is, are they asking for the rate of change of the area with respect to the radius? No. They're asking for the rate of change of area with respect to the circumference. That's it. And it's right there. It's right there. That's really nice. They're like serving it up for you if you go anywhere related to the right direction. Okay, now we'll real quick. you write this, the area of a triangle. Yeah, you're good with that. You need to use the product rule. If you use the product rule and simplify, you end up with 3 over 2 times h minus b. That is only negative when b is greater than h. When b is greater than h. It's negative. All other times it's h greater than b or equal, so it's 0. It's either not changing or it's increasing. Does that make sense? Yeah? I think it's a pretty good one.